Hey class, Miss Anderson here. If you're watching this, I am gone or you were gone, so sorry we missed each other. Today's video is on 5.4, using isosceles and equilateral triangle theorems. Okay, so let's look at the vocab first. An isosceles triangle, remember, has two congruent sides. Those congruent sides are called the legs of the isosceles triangle. So the two sides are congruent. Remember, we used the little marking to show the sides are congruent. Those are going to be called our legs. And then the non-congruent side of the isosceles triangle is going to be the base. It's not always in this format. It can be laid on its side or upside down, but just remember the two sides are the legs that are congruent. The vertex of an angle, or the vertex angle, is the angle formed by two of the congruent sides. So the vertex of the isosceles triangle would be considered right here because these are the two congruent sides. So this one would be the vertex angle. Okay, then the base angles are going to be the angles that are formed by one of the congruent sides and the base. So it would be this angle right here and then this angle right here. And in an isosceles triangle, the base angles are congruent. So we have, those are going to be equal angle measurements. And then the base angle theorem says that if two sides of the triangle are congruent, then the angles opposite them are congruent. So that means that if like side AB and side AC are congruent, then angle B and angle C are congruent. So the sides opposite them. So if this side goes with this angle and this side goes with this angle because they're opposite. So if the two sides are congruent, then the angles opposite them are congruent. And the converse would be then if the angles are congruent, then the sides opposite them have to be congruent as well. So if you know those base angles are congruent, then the sides across, so this angle across would be right here, and then this angle right here across would be this one. So if you know that the angles are congruent, then the sides opposite them are congruent too. So those are going to be our key vocab and our two key theorems for this section. So using those theorems, if we have this triangle and we are given that side FD is congruent to side ED, that means that the two angles across from those sides would be congruent. So across from FD is going to be angle E. So I'm going directly across from that to find the across. So that means that angle E is going to be congruent, and then across from this one is going to be this angle here, which we could call angle F. So across from the two congruent sides gives me two congruent angles. So, and these would be considered your legs then in the isosceles triangle, and this would be the base, and the base angles in an isosceles triangle are congruent. So those E and F are your base angles. Going with the converse says the reverse. So if angle A and angle B are congruent, then the side across from angle A, so this side right here, which would be side BC, would be congruent to the side across from B, which would be side AC. And that was if angle B was congruent to angle A. So that's going backwards. Then this is true. So then using the theorems, if we know that angle Q is 30 degrees and it shows that Q and R are congruent, so that means that this one's also 30 degrees. So that's 60 degrees altogether, and we know that the angles in a triangle add up to 180. So then to find angle 1, you can do 180 minus 60, which leaves you with 120. So the measure of angle 1 would be 120 degrees. Okay, in number 4, it tells us that angle S and angle T are congruent. And then the base angle converse says, well, if you know that angle S is congruent, the side opposite of S is congruent to the side opposite of T. So that means that these two sides, right here and right here, are going to be the same or congruent. So to solve for z, we can use the fact that we know that congruence means equal. So those two sides are going to be equal. And then solve. So adding 15 to both sides, we got 2z is equal to 24, and then dividing by 2. I'm being careful to make sure that my z does not look like a 2. 24 divided by 2 is 12. All right, putting it all together. So if we know that these two sides are congruent, then that means the angles across from it will be congruent as well. So that means that if this right base angle, these are your base angles because these two congruent sides are considered your legs, that means these base angles are the same measure. So this one would be also 6x plus 8. If we want to find the angles first, there's a couple ways to do it. First, you can say that you know that they all add up to 180. So you could write yourself an equation like this using all three angles to make 180 degrees and then solve that for x. Or if you know that the top vertex angle, this would be the vertex angle, is 80, then 100 minus 80 leaves you, 180 minus 80 leaves you with 100 degrees left over. Divided by 2 means that the base angles would be 50 degrees each for the base angles. So then you could just do 6x plus 8 equals 50. Either way, you're going to solve either the first equation that you used or the second one, and you should get 7. X equals 7. Now for the y, we have the sides here. We know that these are sides of the triangle instead of angles, because notice that when you're given an angle, it has the degree measure, and this equation does not have the parentheses with the degrees. So that's one way to be clear. These are referring to the lengths of the sides. And in an isosceles triangle, if these base angles were congruent, those sides were congruent across. So that means you could solve for y by doing 4y minus 2 equal to 2y plus 2. And then we could set or solve. So 4y minus 2y is 2y, and then you have 2 left over, add 2, running out of room a little bit, but 2y equals 4, and then divide y equals 2. I'm going to have to move that up, but okay, I'll do that later. But y equals 2. Hopefully you got it to fit. Okay, a couple more vocab terms. Remember, equilateral means that all three sides are congruent. So they're all the same. Whatever you have for this measure would be the same, And what kind of happens, since the angles across from sides that are congruent, so if this side is congruent to this side, remember the angles across from them would be congruent, so this angle would be congruent to this angle. But what happens when all three sides are congruent, that means that all the angles across from those sides are also congruent. So equilateral triangles are also equal angular, or the converse, equal angular is also equilateral. So when the three sides are congruent, then all three angles are congruent. And remember, if all three angles are congruent, then 180 divided by 3 means that it's 60 degrees each. So in an equal angular triangle, the angles are always 60 degrees. So if you know that all three sides are congruent, then you also know that all three angles are congruent. So you could put a 2x degrees in each spot, and then you can use your triangle sum theorem. So 2x plus 2x plus 2x has to equal 180. So 6x equals 180. So x equals 30 degrees, dividing by 6 on both sides. Or you know that if all three angles are congruent, then each angle is 60 degrees. So then you could just do 6x equals 60, and so dividing would give you x equals 30. And I made a mistake here. I shouldn't write the degree mark there. Because the angles are 60 degrees, x equals 30 is not a degree value. That's just the value of x. So x equals 30. You could say angle R equals 60 degrees, 2 times x. Okay, so for this one then, if you know it's equilateral, all these are congruent, you can set them equal to each other, and really you just need to set one equal to each other. You only use the equal sign one time, so it wouldn't make sense to do this equals this equals this, even though that is true. So just pick one. So if you want to keep it easy, do 2x plus 4 equals 20. I think that would be the easiest one to solve. Minus 4, 2x equals 16, divide by 2, x equals 8. Now, if you would have done 4x minus 12 equals 20, you would have added 12, 4x equals 32, divide by 4, you get x equals 8 again. And if you would have done 4x minus 12 equals 2x plus 4, you would have got x equals 8 again. So either way you do it, since they're all congruent, you can set up any of the equations on a problem like that. But just one equal sign. So just pick two of the sides to set equal and solve. All right, so we'll go with this one. Let's see. So it says that this side is congruent to this side. So I know that this side is 20. I know that's referring to a side measure because it doesn't have the degree marking. So that must be a side length. So if that's 20, that this side is also 20. And then you also know that these three angles are congruent. And if the three angles are congruent, then the three sides are also congruent. So that means that these would all be 20 or all be 5y. So to find y, you would say that 5y has to equal to 20. So dividing by 5 would give you y equals 4. And then we have, let's see, in the angle measures. Okay, so to find this angle for x, we have to use the fact that these are congruent. So you know that these angles here would be congruent. So those two are going to be the same. So really, we have to find this angle right here in order to find what x will be. And so going back to the equilateral triangle, knowing that it's equal angular, tells me that each of these angles are 60 degrees right here because they're all the same, and 180 divided by 3 gives me the 60 for each. And then these two triangle lines make a straight line. So if this is 60, this angle right here has to be 120 degrees because it makes a straight line with the other vertex angle of the triangle. So if that's 120, then I would do 180 minus 120 leaves me with 60 degrees left over. And since those were an isosceles triangle, these are both x. So you can do 2x's equals 60 or divide by 2, and each x has to equal 30. Oops, I said 30, wrote 60. So this x equals 30, so this angle right here would be 30 degrees, and this angle right here would be 30 degrees. Okay. Very similar one here. This time this is 40 degrees. That's referring to this angle measure right here then. And then this one is x degrees, is referring to this angle right here. So this angle for x, since this side is congruent to this side, so this side is congruent to this side, means that this angle and this small angle down here is going to be also x degrees. Since I know that this piece right here is 40, I can find this piece using the linear pair, so they make a straight line. So 180 minus 40 leaves you with 140 for this. And then since you have an isosceles triangle, this is the vertex angle. So these two angles on the sides have to be the same. So if you did 180 minus the 140, there's 40 left over, and then they have to be the same. So dividing them by 2 leaves you with 20 degrees for each of these. And 20 degrees for each, and then we know that this box means that that angle right there is altogether 90, which means that the small piece is 20. There is 70 degrees left over. So if you take off the small piece of 20, so this is 20, that means that the rest of it here has to be 70. Now we have 70 here and 40 here in this triangle. So 70 and 40 is 110. So 180 minus 110 is 70 degrees for this spot. So we would say that x equals 20 and y equals 70 would be our final answers for that one. All right, so one more like this. Let's see. So we have an equal angular triangle, and if it's equal angular, that means it's also equilateral, and so all the sides are congruent. Now we got to be careful with the diagrams because there's some confusing information here. Notice that this one has a degree measure, which means it's referring to this angle piece right here. So, and in an equilateral triangle or equal angular triangle, you know that these are all going to be the same. So these are all 60 degrees, and then the sides are all the same. So you can solve for y because you know that 4y has to equal 28. So dividing by 4, y equals to 7. And then we notice that this side over here is also 28, which was the same as this piece. So we can add our congruent marking there. So then we have a isosceles triangle. The two sides are congruent, which means that this base angle over here is going to also be 2x degrees because they're going to be the same. And so we need to find our vertex angle, which is right here. Now you have a straight line, so you have a linear pair. So these two are going to have to add to 180. So 180 minus 60 leaves you with 120. And then looking at just this triangle, you have 120 degrees right here. So 180 minus 120 leaves you with 60, and then those base angles have to be the same. So dividing by 2, each of them are going to have to be 30 degrees. So to solve for x, you're going to do 2x equals to 30, so x equals to 15. So the angle is 30 degrees, the value for x is 15. The sides were congruent, so the value for y was 7. All right, so just to summarize, we have an isosceles triangle has two sides that are congruent. If the sides are congruent, the angles across from those sides are also congruent. If the angles are congruent, the sides opposite them are also congruent. That is the isosceles base angle theorem. And then we have equilateral. So if all the sides are congruent, then all of the angles are also congruent, and we know that they would be 60 degrees each. And if you know all the angles are congruent, then you know all the sides are also congruent. So equilateral is also equal angular. And then these are called the legs on isosceles triangle. This is the base. These are the base angles. This is the vertex angle up here. So if you know the vertex angle, you know that you subtract the vertex angle and divide by 2 to get the base angles. All right, thanks for watching.